Hello everyone, I am Dr. Jagadha, Professor and Head of the Department Mathematics. The subject is Probability and Statistics. Today we are going to discuss about the topic Repeated Rank Correlation, in which we are going to discuss the topic what we have selected, Repeated Rank Correlation. In detail, we will go about definition of rank correlation and definition of repeated rank correlation. The correlation, that is a relationship between two variables or more variables. About that rank, the quality, how it defined, we will discuss. If the data are repeated rank. The difference between rank and repeated, we are going to do the comparison, and problems on repeated rank correlation, everything in detail we will discuss. So the introduction part, the British psychologist Charles Edward Spearman, first he was the man, he found the coefficient of correlation by ranks. Because one more, the mathematician Carl Pearsons, he defined coefficient of correlation on quantity basis. Whereas Spearman, he defined the correlation, the coefficient of correlation based on ranks, that is related to quality, the characteristics such as morality, character and intelligence, and also beauty. So based on quality, the rank correlation which is defined. In this video, the rank correlation, suppose if the given data are repeated, how to deal that we are going to put into discussion. So first, what is actually Spearman? He defined about rank correlation. The formula for Spearman's rank correlation is rho equal to 1 minus 6 summation d square divided by n of n square minus 1. In this the symbols denotes what? Now we can see it, rho it is there, it's nothing but rank coefficient of correlation. And we can see here b square, it's nothing but sum of squares of the differences of two ranks. Capital N, it's nothing but number of paired observation. So this is the formula for the rank correlation which is defined by Spearman. But our topic is not a rank correlation, repeated rank correlation. So what is the difference? How we can differentiate whether the problem comes under rank correlation or repeated rank correlation? That is the point we are going to focus on in this video lecture. So first, the one problem we are taking, that is ranks of 15 students in two subjects, that is A and B, are given below. The two numbers within the brackets denoting the ranks of the same subject in capital A and B respectively. Here we can notice this is the first student, what he obtained. Now we can see it, this is the subject 1. So now here 10, the two subjects which is given A and B, the total students are 15. That means we should have the 15, the coordinate system, that is 15 brackets. The data should be given within the brackets. The number counting should be compulsory 15. So we can see it 2, 4, 6, 8, 10, 12, 14, 15. The student is 15. So we checked what is given in the question. They are the ranks of 15 students. That point also very, very important. What they are telling us to find. Use Spearman's formula to find the rank correlation coefficient. We are noticing here the data are not repeated. Which formula we are going to use? So this is the formula. Who? Yes, the Spearman. He defined the formula for rank correlation rho equal to 1 minus 6 summation d square by n of n square minus 1. So the first we are going to start the solution for the first problem. The question was which we are asked to do it. So we are starting the solution. What is the formula which is defined by Spearman? That is the formula for Spearman's rank correlation, which is given by rho equal to 1 minus 6 summation d square divided by n of n square minus 1. So the rho is nothing but rank coefficient of correlation, and d square equal to sum of squares of the differences of two ranks, and capital N equal to number of paired observations. So we can see it. Now to substitute in the defined formula by the Spearman for rank correlation, the terms which are there in the formula we needed, because in the particular places in the formula, the terms to be replaced by their corresponding values, for which we are constructing this table. So the construction we are concentrating here. Yes, actually this the topic, this constructed the table is computation of rank correlation. That is, the first one is two subjects, rank in mathematics. That we are denoting variable, because correlation, it's nothing but relationship between variables. The first one is rank in mathematics. That we are denoting as X. What is the data which is given here? 1 to 15. How we obtained this data? We can see it here. So where I am putting the tick, so in the brackets, the first data which are taken here. So those data are here written, completely 1 to 15. The second one is rank in statistics. That we are denoting by the variable y. That is, what is the given in the brackets, the question here. The second one which are taken and be denoted by the variable y. So here we can see it. So all the 15 the data are listed here. So we have come to the clear picture about rank in mathematics. We denoted by the variable x. Rank in statistics we denoted by the variable y. So now the rank correlation, the formula itself, summation d square is there. D square, how to find? Sum of the difference of the ranks. Here, rank in max is x, rank in statistics is y. So we have to find the difference. So that is d equal to x minus y. So we did the differences here. Here we can see it. 1 minus 10 minus 9, 2 minus 7 minus 5, 3 minus 2, 1, 4 minus 6 minus 2, 5 minus 4, 1, 6 minus 8 minus 2, 7 minus 3, 4, 8 minus 1, 7, 9 minus 11 minus 2, 10 minus 15 minus 5, 11 minus 9, 2, 12 minus 5, 7, 13 minus 14 minus 1, 14 minus 12, 2, 15 minus 3, 2. So we completed the job, the work, the calculation related to the capital D. That is the difference of the rank between the two variables we found. But in the formula, the term which is not D, it is D square. So we needed D square to substitute in the formula. So we are finding here D square. 9 square, 81. 5 square, that is minus 5 the whole square. The negative of square is positive. 25. 1 square, 1. Minus 2 the whole square, 4. 1 square, 1. Minus 2 square, 4. 4 square, 16. 7 square, 49. Minus 2 the whole square, 4. Minus 5 the whole square, 25. 2 square, 4. 7 square, 49. Minus 1 square, 1. 2 square, 4. And again, the last data which is given, 2. 2 square, 4. So, very clear picture about our rank correlation. Now, we didn't go. Our topic is repeated rank correlation. First, we have taken a problem about rank correlation. Then, this problem completing, we will move to the problem based on repeated. Then, we will come to know what is the difference between rank correlation and repeated rank correlation. That is a basic idea of this video lecture. So we have to find compulsory summation D square. Why we have to do this summation? Because there is a term in the formula, 1 minus 6 summation D square. This is the part which is there in the numerator of the formula defined by Spearman's rank correlation. So we completely, this complete part we added, we obtained summation D square equal to 272. So now we are writing the formula for the Spearman's rank correlation. That is rho equal to 1 minus 6 summation D square. So here the term which is dominating in the formula, summation D square. That is the reason we constructed the table to obtain this value purpose. The table that is in the previous slide we constructed. The capital N is nothing but how many paired data are given in the question. So here the meaning of that, what they are denoting, the symbol that is rho, it's nothing but rank coefficient of correlation, and D square is sum of squares of the differences of two ranks. Capital N is number of paired observations. Now rho equal to 1 minus 6 summation D square divided by N of N square minus 1. We can see it here, rho which is equal to 1 minus, so the particular here we can see it, summation D square which is replaced by 272. Here the N is nothing but 15 and n square, it's nothing but 225, and the one which we kept it as it is. So now 1 minus, it is written as it is. The numerator, this calculated part, 1632, that the denominator is 3360. So the row value, this is we put it in the decimal format, 0.486. So the final result, what we obtained is 0.514. So now we will go back to our question. So this is the problem. We focused, we concentrated now to find a rank correlation of 15 students. So the 15 students, the ranks of our two subjects, that is mathematics and statistics, we have taken the data which are given, we listed. So this Spearman formula, we needed the term summation d square is needed. Capital N, looking at this here itself, it is given 15 paired data are there. So this part there is no problem at all. But summation d square purpose, we have to construct the table. We constructed. So the table which we constructed on that basis. The construction is over and summation d square equal to 272. Then after finding this and calculation part, we started. The calculation part, this is the formula. Here completely, this is the formula. The summation d square, we substituted, we obtained the final result. So the question given, table we constructed, we did the calculation. So problem 1 in detail we discussed. Now we will move to a problem based on our topic, repeated rank correlation. Equal or repeated rank correlation. So the formula for repeated or equal rank correlation is, so such a big formula, but it's very quite interesting and very easy also. We will see it in detail, this formula. Even how to remember the technique also will be discussed. So rho equal to 1 minus 6 of summation d square plus 1 by 12 of m cube minus m plus 1 by 12 of m cube minus m plus it goes on. Then a doubt which is coming in front of us, plus so on. Then how to stop depends upon the problem data, what is given. According to that, these terms, how many times to be repeated, we have to define. We have to write in the, while writing the formula, we have to note down. Divided by n cube minus m. This is very clear. Capital N, it's nothing but the paired data. So the capital N denotes the paired observations. M, the number of items, that is the data, whose ranks are common. Whose ranks are common? In the sense, the same data rank is repeating. Those is how many times it is repeated. That is denoted by M. So we will take actually from the following data, calculate the rank correlation coefficient after making adjustment for tied ranks. So here we can see it. X1 variable is given 48, 33, 40, 9, 16, 16. Yes, here it is coming a break to us while observing the data itself. 16, which is repeated twice. We have to note down. Next, 65, 24, 16. Again the 16 is repeated. Remaining other data are not repeated. Only the data 16 is repeated. That's what the previous problem, no data is repeated. That is the difference between rank correlation and repeated rank correlation. Only simply rank correlation, if the data are not repeated, we can use Spearman's. But the confusions are started coming on Spearman's, what he defined the formula. If the rank of the data are repeated, the confusions, complications are arising. That's what the formula which is modified. The modified formula only, the previous slide we have seen it. So the next one is Y. Here 13 starting itself, 13 is repeated twice. 24, 6, 15, 4, 20, 9, 6. Yeah, we noticed it. Even 6 also repeated twice. 19. So we have come to an conclusion. Yes, this problem comes under repeated rank correlation because the data are repeating. Here, Spearman's formula not modified the formula. We have to use it. Yes, this is actually a rough diagram. I put the heading also. This is the students' understanding level to increase. This is the method of teaching I adopted. We have to be very careful. 9, because this is the X variable. Completely this data which is given, X. We can see the question once again. This we are focusing. Yes, the students requesting very careful while looking at the data. We should not give room for committing mistakes. Now we are going to focus X variable related data. Yeah, the data. Just now I have shown the question also. Here, ranks. 10 data are there. The least one, 9. Yes, we have to see that I put it rank 1. Next, the next highest, 16. That I have given the rank 2. The next 16 equal only it is there one. That position I have given 3rd position. Next, one more 16 is there, 4th position. Next, we have to search completely the data. We are searching and we found the next one is 24. The position is 5. After 24, which is the highest one? Yes, we got it. 33. That is 6. Next highest, 40. Yes, that is 7. Next one is 48. Fine. The position is we declared 8th position. The next highest, 57. 9th position we have given. Last one is 10th position. Small to big went. The least number is 9. Next is 16, 24. So to the highest one, small to big, we have taken. Here the arrow marks to find the difference between which data are repeated. 16 is repeated. So that's what we can see the arrow marks. That is pink color, the arrow marks. You can see it, the animation part. Yes, 16 is repeated. That is under the circle, the data are written. 16, 16, 16. The arrow marks also showing. But mathematically, See, the 48 is there, we have one position. 33, we have given one position. But 16, the value is only 1. But we are giving the same number, second position, third position, fourth position. It is not possible. How is it possible? That is the reason Spearman's, for the distinct data that is possible, the Spearman's rank correlation. But if the data are repeated, then they did the modification. What type of modifications we are adopting? What it is defined? How the modifications has taken place? We will see it. Now, 16, second position. This 16 we have given third position. Now this is fourth position. We are going to find average of the positions. That is 2, 3, 4. All the positions, the rank positions, average we are finding. That is 2 plus 3 plus 4 divided by how many times our data is repeated? 3 times. So divided by 3. So average we obtained 3. So 16. The rank position we have given 3. This is the modification which is done in Spearman's rank correlation. Fine. Now the data X, regarding X variable data we completed. Similarly, now we have to do the Y related variable data. So we can see it here. Now here Y it is there. Same now 10 actual values are there. The least one we have taken 4. So that is 1. Next is 6. Second position. And we are searching completely, very carefully. We have to pay more attention while selecting the data. Small to big we are selecting. So we are searching the data. We are finding ourselves, yes, one more 6 is there. So that 6, we given the position 3. Fine, our job is over. Next, 9 it is there. We have given the position 4. Next, 13. Fifth position. One more 13 is there. That is 6th position. 15. 7th position. 19. 8th position. And 20. 9th position. Last one, 24. 10th position. Yes, here also we can see it, the 2 colors to make it identify more to increase our understanding purpose. 13, you can see it, the animation which is repeated. So 13, that is 5th position and 6th position. Average, we have to do it. So 5 plus 6, 11. How many times our 13 is repeated? 2 times. So divided by 2, 11 by 2 is nothing but 5.5. One more data also repeated. Yes, it is nothing but our 6. It's a very quite interesting problem. 6 is repeated 2 times. So the position 6 we have given, the position 2. Here the 6, here the position we have given 3. So we can see the animation part. So 2 plus 3 divided by 2. Average, very simple formula. Sum of the observations divided by number of observations. So 2 plus 3, 5 divided by 2, we obtained 2.5. So, but I am requesting the students this slide and previous slide to explanation purpose, which is kept in this slide. In the examination oriented, it's not required. To understanding purpose, this method of teaching, it is adopted. So now We can use it if the students this any careless without careless mistakes. If the students want it, they can put it in the rough page, rough the answer sheet, rough page. This to be done. In the fair pages, it's not required. So we are going back to the question, that is x variable, that is the full complete question, and y the variable, and this is the first actually rough diagram. That's what I kept it. When students also in the answer sheet, rough place they can put it. Because here in this particular only we are declaring the ranks. We have to be very careful. If we do any mistake here, whatever we are going to do in advance, in forward, everything will go wrong. So this part, paying more attention, is very, very important. So the second one also, y variable also, this diagram we adopted. So now the given data, the ranks, if they are repeated also, with the help of average formula, we declared those data also ranks. Now rank declaration part is completed. To substitute in our modified formula, now we have to move the problem towards that. Yes, now we have to do constructing the table. So we can see it. The table actually we are going to construct. Yeah, the table construction is over. The heading of the table, computation of repeated rank correlation. X, yes, this is the data which is given in the question. Rank of X, we can see it. I am circling 16 because just now we discussed the rough diagram. 16 which is repeated 3 times, and this is the position, the rank position 3 with the help of average formula we did. Y, the data which is given in the question, it is written. Rank, here Y, here we can see it. 13 which is repeated 2 times, that average is written here. And 6, I am circling, that is also repeated 2 times, that is also written here. Other positions and all we have seen, they are written as it is. Capital D, it's nothing but rank of X minus rank of Y. So we have to do the difference between rank X minus rank Y. So we can see here this 2. 8 minus 5.5, 2.5. Next, here we can see it. 6 minus 5.5, 0.5. 7 minus 10, minus 3. 1 minus 2.5, minus 1.5. 3 minus 7, minus 4. And 3 minus 1, 2. Then 10 minus 9, 1. 5 minus 4, 1. And 3 minus 2.5, 0.5. And 9 minus 8, 1. So D square, the term which is very, very important. Now 2.5 is 6.25 and 0.5, it's nothing but 0.25. Minus 3 square, 9. Here 1.5, 2.25. Minus 4 the whole square, 16. 2 square, 4. 1 square, 1. Again 1 square, 1. 0.5 the whole square. It's nothing but 0.25. 1 square, 1. The table construction we completed. Why we have to construct this table? only the answer. To substitute, we needed this a d square term which is dominating in our formula. And we have to find summation d square also. Because in the question, in the formula, summation d square is a term is there. So we added, we obtained the result 41. So completely we can see it. This is the question we are focusing. Or we did the diagram 1 we did. And second, here also we focused on that is Y series rank declaration here. And we constructed the table. Yes. Now the formula for repeated or equal rank correlation. So this is the formula, fine. We found this summation d square value also in the previous slide. We constructed the table. To obtain this result purpose only, that construction also. Everything is fine. Now, what is this m? And in the formula also, plus so on, it is there. Then how many times we have to write this repetition? That is a question in front of us now. We have to face that. Facing that, we have to solve the problem. Yes, we will do it. Now, capital N, we know it. Number of paired observations. And M, this part only now. That is the number of items whose ranks are common. The first data, X, there 16 which is repeated 3 times. How many times repeated is important. The data not. The data how many times repeated? 3 times. That is our M. M equal to 3. And what about in Y? In Y variable under the data which are given, in which our 13 which is repeated 2 times. So M is 2. Again the same under the variable Y, the data 6 which is repeated 2 times. So M equal to 2. Fine. So now M equal to 3. For the 16, the data purpose, M equal to 2 for this 13 data, M equal to 2, the data 6. So we have to write the formula M 1, 2, 3. 3 times the formula we have to write. Now we have the picture what we obtained about the problem solving is very clear now. Yes. Yes. Here we can see it. 1, 2, 3. 3 times we have written. We didn't put here plus so on. Not required. Whereas the previous slide, here so on. Here actually in this slide, we have written the formula. Whereas the next slide, according to our problem, the formula we have written. Our problem, the data's repeated. What are the data's repeated? Yes, 16 is repeated, 13 is repeated, 6 is repeated. So here 13 is repeated, 6 is repeated, 16 is repeated. So 3 times we have written. So correctly we have to do the substitution now. 1 minus the 6 is written as it is. Summation d square, what we constructed the table. From there we have written 41, 1 by 12. Here the m is nothing but 3. Here also 3, because 3 times it is repeated. Whereas here the M is 2. 2 times the data is repeated. Yes, over. Again here the M is 2 times repeated. So this is for (16) purpose. The first, this one, M equal to 3. Next one, 13 purpose, that is repeated twice, M equal to 2. And 6 purpose, M equal to 2. So here we can see it 3 times. Here also we can see it 2 times. Here also 2 times. Suppose in case any data, if it is repeated more, the formula one more time we will extend. That is the logic behind this formula. Now we will concentrate the simplification part. 1 minus 6 of here 41 is there, plus here this 27 minus 3, 24 divided by 12, plus here 8 minus 2, 6 divided by 12. Here also 6 divided by 12 divided by 990. So 1 minus, here we can see the numerator part. It's nothing but 264 divided by 990. And here we are giving this fraction in the lowest decimal part, 0.2666. So final result, we obtain 0.7334. So now this is the second problem we completed. So the first, so the question actually, we are actually concentrated, and we moved to the declaring the ranks. This is a simple actually we adopted. And for the Y series, this is the diagram actually, it is done. The formula to substitute it, this is the table we constructed. We found the value, this is a very, very important thing. And calculation part. Here M is taken 3. This M has taken the role of 2. Here also the rule of 2, because they are repeated 2 times, whereas this is 3 times. Finally, we obtained the result 0.7334. So we will move to same one more problem, repeated rank correlation. So a sample of 12 fathers and their sons gave the following data about their elder sons. We have to find coefficient of rank correlation. We have to decide that the given problem comes under rank correlation, only rank correlation. The data are distinct, they are not repeated, we can adopt a Spearman. But if the data are repeated, what we have done, what we have discussed the previous problem, such a way it should be done. Yes, the fathers and sons, yeah, the data 65, 63, 67, 64, 68, 62, 70, 66, 68. Yes, 68 is repeated. 67, 69, 71. The 68, the data which is repeated, it gives an indication to us. This problem comes under repeated rank correlation. So the next one is 68, 66, 68. Again in this also 68 repeated. 65, 69, 66, 68, 65. Yes, 65 also repeated. 71, 67, 68, 70. Now the data are repeated. How to? 65. Which rank position we have to give? For 63, which rank position to be given? And 67, which position? So the father, we will assume one variable. For the son, another variable. What are the data are given? The rank position to be given. Whereas the first problem, what we discussed in this video lecture, 3 problems I am discussing. The first problem, only rank correlation. There is no repetition of data. Whereas second problem, the data are repeated. The similar type, now the third problem also. The data are repeated. Then how to declare the ranks? So to declare the ranks, some rough diagram we can follow to avoid the careless mistake. Yes, we can see it now. Rough diagram. The data, yes. What is given in the question? Yes, the data we kept here. 12. Just 1 to 12 I kept it. Why I am keeping 1 to 12? Because 12 data are there. It's a common thing. 12 data are there. Each data one rank I am going to give. So I put it 1 to 12. Fine. Now, here I am seeing completely the 71 is there. I think so that is the highest one. Yes, I have given the first position. 70, the next lowest one. Here big to small I have taken. Any order we can take it. Either small to big or big to small. So 70 I have given the next small. Second position. Next 69, third position. 68, fourth position. I am searching the data. Yes, I noticed that 68 is repeating. So that 68 is fifth position. Next, the lowest one is 67, sixth position. It's a very quite interesting problem. 67, seventh position. And 66 is eighth position. And we are noticing, is there? No, 66 is not repeated. The next lowest one is 65. That we have given ninth position. And 64 is 10th position. 63, 11th position. 62, 12th position. So to understand purpose, here we can see the animations part. That 67 is repeated 2 times. So which is kept in yellow color, the arrow marks also. And 68 which is repeated also. So we can see the first 67. It is repeated 2 times. That is, position is 6th position and 8th position we have given. Sorry. 6th position and 7th position. So 6 plus 7 divided by 2, 13 divided by 2, which is nothing but 6.5. Now, one more repetition is there. That is for 68. That is 4th and 5th positions we have given. So average to be done. This point is very, very important. The average to be done if the data are repeated. So 4.5. For 67, we declared the rank 6.5, whereas 68, we declared the rank 4.5. So complete the under which the X variable, we finished the rank declarations, that is rank positions. So now the next one is Y. So 1 to 12 it is ready now. So 71 highest, 70, now 69, the next one. Lowest one, 68. 68. Yeah, here the 68 is which is repeated 3 times. The arrow marks are in different colors. 68, 68, 68. One more 68 also is there. Yes, 68 is repeated 4 times. The positions are 4, 5, 6, 7. The positions are. So now we have to find their averages. Before that we can see it. About 67, we have given the position 8. 66, 9th position. 66 again 10th position. 66 is repeated 2 times. 65 11th position. Again 65 also repeated 12th position. Here 3 datas are repeated. 68, you can see the animation part. It is repeated 4 times. So we have to find the average. So the positions, the rank positions, which is written here. 4, 5, 6, 7. Summation we are doing. Addition we are doing. So 4 plus 5 plus 6 plus 7 divided by 4, it's nothing but 5.5. So the next one is 65, which is repeated twice. That average, the positions average, the rank positions average. 11 plus 12 divided by 2, that is 11.5. Next, 66, which is repeated twice. That is 9 plus 10 divided by 2, that is 9.5. Completely under X variable, under Y variable, that is your father and son, under which the data are given. As we are doing the correlation topic, we are learning the correlation. It's nothing but relationship between the variables. So the rank we declared, the data are repeated. This is the easiest way to avoid the careless mistake. On the purpose, this, even students also, they are requested this part in the rough column doing to avoid, they can avoid their careless mistakes. Yeah, now we will move to the part of construction. Yes, fine. We are going to constructing. Yes, beautifully we are constructing the table. Yes, construction is over. That table, the heading is computation of repeated rank correlation. Father, X variable, under which the question what is given, the data are written. Rank, we are declaring. We declared the previous slide, that is through which, with the help of the rough diagram, we can see it here. 67, here also is there. That repeated one only I am marking. And 68 also, yes, 4.5. Here also we can see it. The sun, that is the variable Y, the data are written. Next, the rank, what we declared. Here we can 68, it is repeated 4 times. So 5.5, 5.5, yes, the rank. And 65, it is repeated 2 times. And one more also, 66, that is repeated 2 times. So what we declared, the ranks are written. So the completely, the rank, what the positions we are giving to the each data, it is written here. Now capital D is required. That is capital D, it's nothing but the difference between the ranks. So rank of X minus rank of Y. So here we can see it. 9 minus 5.5, 3.5. 11 minus 9.5, 1.5. 6.5 minus 5.5, 1. And 10 minus 11.5 minus 1.5. And 4.5 minus 3, 1.5. 12 minus 9.5, 2.5. 2 minus 5.5, minus 3.5, 8 minus 11.5 minus 3.5, 4.5 minus 1, 3.5, 6.5 minus 8, here minus sign should be there, minus 1.5, 3 minus 5.5 minus 2.5, similarly 1 minus 2 equal to minus 1. So d square, yeah, this is the term which is dominating in our formula. So all the squares we have done it. 3.5 square, simple 2, 3 data centering. The negative of squares is positive. So there is no possibility of occurring negative numbers under which d square, because negative of square is positive. So everything positive, all the data, 1 square 1, 2.5 into 2.5, 6.25, 1.5 into 1.5, 2.25. Completely the d square, the calculation part is done. We needed now summation d square. So summation d square equal to 72.5. So the formula for repeated or equal rank correlation coefficient is 1 minus 6 of summation d square plus 1 by 12 of m cube minus m plus 1 by 12 of m cube minus m plus so on by n cube by n. So the capital N, it's nothing but a number of paired observations. M, how many times the data which is repeated? That is our small m. Generally, we have written the formula. Now, 67 in x under the variable x, that is our father. 67, which is repeated 2 times, m equal to 2. And the same x, our 68 is repeated 2 times, m equal to 2. Next, in y variable, 68 is repeated 4 times, m equal to 4. Next, our 65 under the variable y, it is repeated 2 times, so m equal to 2. And what about here? 66, which is repeated 2 times under the variable y, so m equal to 2. Now, how to write the formula according to our problem? So we can see here. So the previous slide, how many times m? 5 times. So we have to write the formula. Yes, 1, 2, 3, 4, 5. Now the formula here we have written according to our problem. Fine. Now summation d square, the value already we calculated, that we are going to substitute. We are going to replace summation d square. Yes, we replaced it 72.5, and here the m is 2 times repeated. Here also m 2 times repeated, whereas our here m equal to 4, because we know our under the variable y, our 68 the data which is repeated 4 times. Here m is 2, here m is 2. Capital N, total 12 paired datas we have. So 12 cube, 1728 minus 12. Everything, what are the values we obtained from the table construction, and how many, that is through the rough diagram we did, the rank positions giving. With all the help, we filled the data of our defined formula. Only the calculation part which is left over, 1 minus 6 is written 72.5, and here 8 cube minus 2, that is 6 divided by 12. Here 6 divided by 12. Here 64 minus 4, 60. And 6 divided by 12, 6 divided by 12. So 17, 16. So the final result, so 1 minus the fraction 477 by 990. So the decimal part is 0.278. The final result is 0.722. So now, so based on this, the formula we 5 times we have written and we did the substitution also. So this is the third problem we discussed, and the data repeated. On that basis, the formula we selected, repeated rank correlation formula. So the ranks we declared through this rough diagram. And for the y variable, rank declaration we did. And to substitute, we needed summation d square. We did the construction and we moved to the calculation part. Final result, we obtained 0.722. So we will come to a conclusion of this topic, repeated rank correlation. So first, Spearman, he is the person, he defined the formula for rank correlation under the concept of quality, intelligence, characters. Based on that, he defined rank correlation. But where is the problem we faced? Suppose in case the data are repeated, the complications arise. So on that basis, the modification which is done, that is modified the formula is 1 minus 6 summation d square plus 1 by 12 of m cube minus m plus 1 by 12 of m cube minus m. What is the concept behind this formula? How many times the data are repeated, those many times this 1 by 12 of m cube minus m which is repeated. For which first initially to understand what is rank correlation, what is repeated rank correlation, even in the topic, even though the topic repeated rank correlation, to understand the comparison between rank correlation and repeated rank correlation, we have done the first problem under rank correlation. The next, we repeated rank correlation also, we focused it. So we can see this is the first problem we constructed. And this is the second problem. It is the data are repeated. This is the third problem. Data are repeated. So completely 3 problems, different, is complicated, but in a very simple way it is discussed. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.